Hello everyone. Sorry for the problems caused. I just made a mistake and accidentally ran the streaming before it should have been started, and under panic mode I accidentally stopped it. So this is the reason I had to create a new one, because YouTube doesn't support a different approach to like restarting videos. So I think we can start now. And our first topic by raini.dev. This is called Semantic Versioning at Scale for some reason. It was updated, so it's called Clean Project History with Semantic Versioning and Changelogs. It was created by me, and I'm a solution architect and I work at EPAM. My name is Sergey Orlov, and I'm commonly known on the internet as Pristine. You can follow me on Instagram, Twitter, GitHub if you like. And I decided to create this workshop and raini.dev in general for a set of reasons, and I'd like to first tell you about what raini is. So we have this very boasting motto, raise advanced expertise globally, but in fact we came up with the idea that there is a lot of developers' knowledge scattered around the world, and it's very difficult to elicit because it either lives in some blog posts, books and stuff like that it's just hard to follow, or it is located in and buried deep in the minds of experienced developers. So we thought of creating some kind of a space that could be filled with the information by all the community around the world. So in this case, we can surely say that being global means accepting information from different sources, from different people. And we thought that open source approach to doing this could be effective, because there are a lot of advanced engineers around the globe, and it's just a place where we could extract the information. So you could think probably that raini.dev is a kind of Wikipedia, video Wikipedia about software development, where different people around the world can collaborate to make the information more interesting, convenient, and high quality. So doing this, I thought that probably when people created Wikipedia, the first pages were filled in by themselves. So this is the first workshop that would outline some kind of information that could be used by developers worldwide, I hope. And without any more taking additional time, let's jump into agenda. So in this workshop, we'll discuss versioning in general, then we'll deep dive into semantic versioning, which is by far the most common way of versioning. We'll mostly talk about versioning related to releases and stuff like that, that is human readable, because there are different kinds of things that could be considered as versions, but this is out of scope. We'll talk about it at the very beginning. Then we'll find out what changelogs are and what purpose they serve and how we can use them, and why they're important or not important. In the third part, we'll look at commit conventions that we can use to put at our help to get some use in our scenarios about versioning. And finally, we'll define the right time for bumping our versions, and we'll also talk about maintaining multiple versioning flows in terms of one project. And after we cover all the theory given here, we'll move on to writing code that will actually do all the stuff, most of the stuff that we'll talk about today. It's going to take some time, so we'll have a few breaks, maybe 15-minute breaks during this session. So I suggest you to start, and the very first thing we should do is to define what a version is. And according to Wikipedia, software upgrade versioning is the process of assigning either unique version names or unique version numbers to unique states of computer software. This definition implies that a version is a name or a set of numbers, and it points out to a unique state. And this is commonly true, and every single commit you do in Git is actually a version. And it points out to a unique state that you can change. So if you have a commit and there is no real chance to change the state of the software it points to. But what we're going to talk about today is, apart from this uniqueness, we'll call it immutability. There are other things, and among other things, there is a very important topic, human readability. Because when we talk about releases, we can directly use commit hashes, and probably that's okay, but it's not very convenient, and it doesn't provide us with any understanding about what the state of computer software is. And this is why I would say that a version, in our sense that we're going to talk about today, is a unique human readable pointer to a specific state of computer software. And saying this, I want to show you a small example, a very small thought experiment, where I'll show you two things, and you should just try for yourself to define which provides you more information about what's going on. So both of these are in fact versions. So we imply that they are unique and they never repeat. They point out the specific state. And the second one, with sets of numbers, is in fact using commit hashes. So the problem with this approach, as I've said, is that it is not human readable. You can see that it's even difficult to understand what happened first. Even if we know how it works, probably there is some kind of cryptography, and we can, if we know, probably I don't, but maybe there's a way to deduce what happened first. But even this is difficult. But when we talk about this v3, v4 thing, it's much easier to understand what happened first. When we talk about human readability, we do not say that the intuition that holds about versions is always held. When we talk about this, we mean that we think that version 3 was before version 4. And this is what human readability stands for. So when we can infer something from the information and process it in our mind and make some kind of understanding about what happened, this is called human readability. I mean, at least this is what I mean when I say human readability. So I think that this is quite self-explanatory why human readability is important. And now let's talk about let's stop talking about the versions themselves. So it could be anything. Now let's talk quickly and briefly about where they should live. I mean, where to store versions? Well, version control systems look like the great place to store versions, including the human readable ones. But what I encourage you to avoid is not to use commits because they're not human readable, as I've said, and not to use branches because they're mutable. They're not bound to specific states. So a simple example could be when you have a team that relies on your code base in a way, and they want to write some to create some integration with you, and you provide them a branch, but after some time the state of the branch changes, and all the integration done may be broken. So this is a bad practice generally to me, and you should probably avoid using branches. But you have a very nice and concise thing in Git and many other version control systems, which is called tags. So a tag is a different way of defining a head reference where you create something like a new branch, but this branch cannot be changed. And this is very convenient because it doesn't provide any ambiguous flow. It's like working with a branch. But what it also gives you is a way to annotate your tags and provide some message that describes what the tag contains or any other relevant information. So this can be used for many reasons. but this is just a good place to have your versions. We'll talk about how to make versions later on, but this is the great place to have them, and we will keep this notion in mind when we'll follow along. And moreover, vendors like GitHub and GitLab provide a special UI place, UI section, which is called releases, which wraps up tags, Git tags, and provide special additional metadata about your releases. So I'm not alone in this notion that the tag is the perfect place for holding your versions in. So let's talk about approaches to versioning, because we're going to talk about semantic versioning later on, but it's not the only one. At the higher level, as we've seen from the definition of versioning, there are two things. One is incrementing, creating words or phrases, and the second one is incrementing numbers, because they're either names or numbers. We're not going to cover naming at all, because it's generally more related to other reasons like marketing or something else, which is not that technical, because you probably know that macOS Catalina is similarly version 10.16 and 10.16.4, which means that this is not that much immutable. But when we talk about immutable versions that are more technical, we have two mostly widely adopted ways of doing this. When we include the date of release in our version, or when we create sequence-based versioning. So these are the examples. You probably know them. Windows 95, Microsoft Office 2007, Ubuntu 19.10, which is October 2019. WebStorm, which has slightly different approach to this. They have the year, and then they increment numbers. So this is not much 2019. It's just 2019 version 3. And when we talk about sequence-based versions, we have some sets of numbers, and we just increment them. So we can outline Windows 10, Angular 8, and stuff like that. We can use some special syntax, but generally it's all about the same thing. We just +1 to something. And ideally and generally, sequence-based versioning is the closest one to uniqueness, because you never repeat a number and you have an infinite set of numbers that you can use to create new versions. Some approaches vary, and it's also worth mentioning that you are not bound to using direct sequence. You can skip some versions, and that's okay. Like Angular did with version 3, or Windows did with version 9. That's completely okay. But the thing here is that everyone should understand, at least in the team, why the version was skipped. I mean, there are probably some reasons to do so it's a good thing for everyone to know. But what we're going to talk about today is semantic versioning, and semantic versioning is a pinnacle of creation. Human is a pinnacle of creation, and semantic versioning is the pinnacle of versioning. As SemVer.org, the official website, by the way, you can use the QR code to get there. The official documentation outlines that under this scheme, version numbers and the way they change convey meaning about the underlying code and what has been modified from one version to the next. And this is a big difference, actually, because prior to semantic versioning, there were versions that looked like semantic versioning. So it was something dot something dot something else, probably. At least the structure was about the same. But semantic versioning that was created by Tom Preston Werner, who is a co-founder of GitHub, proposed that, in fact, the version consists of 3 separate versions. The Z that I outline here as Z is a patch version, so it gets updated on specific reasons. A minor version, Y, that also has specific reasons for being updated, and a major version that also has reasons for being updated. When we talk about semantic versioning, we usually tend to read right to left, not left to right, because it's like the order of importance in our changes. We'll quickly dive into when we should bump the versions. And when we talk about patch version, we must bump it if we have backwards compatible bug fixes in our set of code. When we make a change and when, not when we make a change, when we've done some changes and we are about to release, we should check whether our code that we bring in has only backward compatible bug fixes, and in this case we bump the patch. When we talk about minor, it's a bit more complicated because it's like the very common place to be updated. We update minor version when we have new backwards compatible functionality in our public API. We also bump it when we have deprecations in our public API. And since semantic versioning version 2.0.0, we may bump substantial new functionality or improvements when we introduce them in our private code. What is important is that when we bump minor version, we must reset patch version to 0. And when we we may include patch level changes as well when we bump a minor version. So let's have a short talk about public vs private API. This is one of the reasons why semantic versioning is usually considered to be a versioning scheme that is suitable for open source projects and stuff like that. So it's like if you have a project on GitHub or kind of pet project you run for yourself, it may be suitable. But in fact, semantic versioning is much more powerful. It can be applied to almost anything. You can version your files there this way. You can do anything with it. And the only thing you need to understand is that public API is not just the function you export in your public NPM module. It is any kind of interaction with your source code, with your code, with your application. It may be in an API endpoint. It may be a function that you export. It may be a page in your book. It may be whatever, anything. So when you make changes to the way people are already interacting with you, this is usually called a break and change. We'll talk about it a bit later. So when we talk about something being backward compatible, we can give an example of an API that added a new value into the response. So it didn't change all the previous responses the same. It's just a new value that you return, and that's okay mostly. And another option, probably a more sophisticated one, a little bit more sophisticated one, is when we add a new value to a new key value pair into our request to our API, but we have a default of value for it. So if someone sends us in the response that was compatible with our previous version, we still have a default value, and having that default value, we can still produce the output. So it doesn't change anything; it just extend what it is already. But when we break something, when something is changed and it doesn't work anymore the same way it did, this is called a backwards incompatible change. And when we make those, we must reset our bump our major version. When we bump our major version, we should bump a patch and a minor versions to 0. We should reset those to 0. And when we bump a major version, we can include minor and patch level changes as well. So this is important to note that not every single time we understand that our change is breaking or not, but it's not very difficult to reason about. You just need to remember that when we do something, we usually do it for someone else outside. When we talk about UI, for example, imagine yourself in a situation where you face the change that you are actually making. I'll give an example that's I think happened to me a couple of times. When you use some kind of software, a website, and there is a button that you always use for some reason. I don't know, a list and a button to add something into a list, and after an update it accidentally disappears, and I can't find it. I don't know where to find it. I don't know if it was removed or moved somewhere else. And in fact, to me, I don't know if it is true or not. It's just opinionated thing that I'll say, but I think it's a break and change, because nothing else now works the same for me. I can just execute the same workflow as I did before this update. So when we talk about picking the right thing to bump, we should always remember that absolutely any change that breaks what was before is a reason for a major update. So if you think CSS, for example, is never a reason for backwards incompatibility, that is wrong. If you think placing a button to a different place is not a break and change, that's wrong. So just adding something or fixing something, preserving all the same things in their same places is backwards compatible. Okay, so now let's briefly talk about changelogs. There is another open source thing that is widely adopted, which is called keep a changelog. You can use the QR code here. It describes a lot about changelogs, and I've put it here, and you can read through. You can just go to the documentation and read it there. But what they say is, again, restricted commonly to open source stuff and keeping repositories that are public and available to everyone. And in this case, it's fine, but I would like to paraphrase it and keep a changelog a simple way. A changelog is just a place which contains a curated, chronologically ordered list of notable changes for each version of a project, which means that a changelog is just some kind of space in your repository or elsewhere where you have chronologically ordered changes. Not all of them, but only the notable ones that have an impact for those who use your application. And it outlines the definition for each version of a project. If you have a version, there must be a reason for it. If it happened, please define what changed. And why to keep it? Why do you need a changelog? So first off, it makes it easier for contributors to see what's going on. Imagine a person in your team who left for a vacation, and they come back and they see a completely different project because they've been there for like a month, and you've been iterating very fast. So a changelog is a good place that helps them to jump in. Another thing why a changelog is a convenient thing to have is that you are able to inform users about your changes. So when we have a single source of information about what changed, we can use it in multiple ways. Again, we can propose those changes to, not propose, but we can translate those changes into our users. And this is one of small things that I love about some companies, is that when they make something changed, you always know how to use it now. So some of the companies just make amendments to their UI feeling like it's just UI no matter what, so forget it. And some of them always inform you, and it should be short and concise to be easy to read, but generally being able to inform users about changes, not only users but probably any kind of stakeholders of your application, it's a good thing to do. And the third thing is that you can reflect on the progress, because opening and closing Jira tickets is okay. You can put a tick on everything you do, but it doesn't really reflect the progress. It reflects the process. But it's like, it doesn't matter what you did, it only matters what you've done. And this is the same thing. You can show everyone what you were doing, what you've done, what you completed, and what the state is now, and what it was before that. And generally, I think the phrase that's the very first phrase of keep a changelog reasoning about who needs a changelog, it's people do. There are so many reasons how we can use it, and people can leverage it in many ways. So I think now it's a good time to move along and talk about this. So this is the source of truth for changelogs. At least in most projects that I've seen, the very first source of truth for what changed in your codebase is Jira tickets. When I mean, it might be Trello tickets, I don't know, Asana tickets, whatever tickets, but I cannot really understand the reason for defining results by expectations, because planning is, plans are just sets of expectations about what should be done, and I think there are a lot of nines after the point in 99% of when expectations the results do not meet expectations in full. I mean, they're not always worse. They are commonly not lower but higher than the expectations. So I don't think Jira tickets are a viable option to define what changed. They're not related to it at all, but this is what I commonly see in most projects. If we go deeper into where we can get information about what changed, is the pull requests or merge requests. A good place to start, because there you can find sets of changes that were like applied to our current state of our code base. But the biggest problem of pull requests is that they get buried under different pull requests very quickly, and going through the history is quite complicated. Another thing is changing the changes in the commits, which is like a 100% source of truth, because the commit contains exactly what was done. But the problem about commits is that you have to know code. You have to understand the previous states of the software, and it's not very convenient all the time to see what changed. And the third thing about commits is that they do not actually tell you when this change was applied. I mean, you can see when it happened, when it was committed, but the commits themselves do not tell you when it was applied to the code base. So in all those three cases, you like kind of miss the information, some kind of information about your changes. And at the very bottom there are commit messages, and this is quite a funny thing, because I've heard many people say that, well, developers write whatever in those commit messages, never trust them, just force them to write meta information about what they do, like Jira tickets as well, or something else. And I partly agree with that, because like I've seen so many commits doing fix or add some file or stuff like that, so it's not very informative. But the problem about this approach is that no one trusts commit messages, and if they did, they would be the most efficient way to translate the changes that were applied to the code base. This is why I like them. And the only thing that we need to do is just to shift our mindset a bit and say that Jira tickets are in fact worse than commit messages. In fact, everything is worse than a good commit message. And we can teach developers to write commit messages by just saying that every commit message that they write will be seen by end users. That's it. That's quite easy, because they write code. If you don't trust what they write, you should probably close the project. And that's not the case. They do write the code, and we use it, so it's fine. Developers are clever people. We just need to explain what is needed and why it is needed. And this approach usually leads to a very big and complicated problem, because this is what happens when someone on the project creates a Jira release, version 1.2.9.3, and whatever, just arbitrary numbers. It doesn't reflect anything. It's not a version. It's just the latest sprint number. This is it, nothing else. And due to that fact, it is not usable. So you can't effectively use the changelog and the changes that you've published, because there is no 100% truth about this. It might be falsy. Some of things about what is included in Jira tickets might be broken. Some of it might not be implemented and stuff like that. So it might be implemented in a different way. You can't like build the interactions between different releases. It is, we did this, I think, and that's what Jira release means. To fix the problem, as I've said, we just need to consider commit messages as the very top thing in our source of truth. And in this case, we'll see all the relevant stuff at the very top. And using the commit messages is very convenient because we are not bound to the code that was written in commits. And we don't really need to have every single PR to provide any information. And by far, it's much more efficient than Jira tickets because it provides real information about what was changed, but not what was planned. And saying this, I think we should talk about how to write those commits, because this is kind of important. There are widely adopted conventions about how to do this, and I think you've probably heard of them. There are conventional commits, Gitmoji. There's one called Turbo Commit. I didn't include it because they only have a GitHub page, which is not that beautiful. But there are conventions that are widely adopted. You can just take one of those and use it for your own needs. But this is not usually the case. For most big projects, some things will be difficult to implement from those things. In this case, it's very simple to create your own convention. When we talk about creating conventions, there are two things you should keep in mind when you're going to implement one in your project. So what you need to understand is that every single commit may have a type. So in your system, if something has a type, there must be a reason for it. A type might be any string. You just need to adopt it. And if a commit has a type, it must be one of those adopted types. So to put it simple, if you have a special type for commits that fix bugs, you should say that this commit is this commit must be marked with a specific type and start with colon bug colon space. So this is a convention. It's an adopted string, which means that for every bug fix we use this bug emoji, and for every single commit that fixes a bug, the commit type must be of that type. When we talk about semantic versioning, the adopted types must cover these four categories. One is fixes, so you need some kind of commit type for fixes, one commit type for features, one commit type for deprecations, one for breaking changes, and you optionally may create a commit type for big changes in your internal code base. It doesn't mean that they have to be different. You may put them together in terms of semantic versioning and just use the same things for the same type for different things. Like you can create features and deprecations as one single type, or you can just make compound types from them. But the only thing you must remember is that the fix type must relate to the patch version. Features and deprecations must be covered for minor versions, and breaking changes must be for major versions. If we talk about conventional commits, they have a fix type and a fit type. They don't have a deprecation type, as far as I know. And they provide a breaking change in commit metadata, which means that it goes below the end of the commit and its description. You put a blank line, and there you say breaking change with all capital letters, put a colon, a space, and then you describe the breaking change. There might be a use case for that. It doesn't mean that every commit must start with a type. It's just a type must be defined, and there must be a way to represent it as a string, because you'll always take commit types from commit messages. All the rest of all of the stuff in the commit is related to changelogs. So every commit must have a short description, because this is going to be the information that is going to be read during code review, and this short string must explain what's going on briefly. It doesn't mean that you should always think about describing all the changes in your commits, in your huge commit, into like 150 letters. It only means that you shouldn't do such big commits, because, like, you know, if you can't explain something, I'd say there is a good rule of the thumb about commit atomicity. When you create a commit and you are going to like create a message for it, and you start typing the message and you use the word "and," this is the right place to like decompose a commit, because there's probably two of them. So every commit may provide additional long description in the body, and you can use this for many reasons. Like I'm almost sure that something like that can be done for creating blue posts like Blizzard does about their games. So a long description that provides some important information in terms of business definition, or probably defines some specific things about the commit and the changes. So it might depend on the project that you're working on, but generally it's a good thing to do, and you probably feel that if you create 50 characters of describing something and it is not yet understandable, you can provide a long description in the body. To provide the longer description, there is convention to put a blank line, so you kind of return your caret and then return your caret again. So there's one blank line between the first line and the description line. Another thing is that commits may reference issues, and this is a thing that is supported by like every major vendor, including Bitbucket, Jira, I don't know, GitHub, GitLab, all of them do. When at the very end of your commit, when you complete, you again create a blank line, and there you write that your commit closes number and issue number. So the very ugly thing I usually see on many projects is that developers write they open square brackets, or I don't know, curly brackets, whatever, any brackets, and then they're inside of the very first the very first thing they put is the issue ID from Jira, I don't know, or whatever. So you're actually wasting useful space, because no one needs, in fact, the link. Only the system needs the link to count your commit as being related to the issue. And you should probably put it at the very end, because you save up some space, and this is very convenient in most cases, because I know the first line is almost never readable if you have some metadata going before it, and you like have 20 characters left after that for the code reviewer to see it. So I think this is it, and all of that is unrelated to the versions. And now I suggest to talk about different steps of our code, and the fact that when we create a version, all the stuff we've been talking about until now is we were talking about creating versions for releases, but there are different states of software, and this code maturity funnel probably briefly describes that our software is either in development or being tested, and finally, when all of it is done and it is accepted, it becomes deliverable, so we can create a release and just ship it when we are ready, or ship it right now, so it depends. But most of these things can be used for different scenarios, and if we think about it, our deliverable state is called a release, but before that we test it, so we can say that this is a release candidate. If we work in agile environment, this is particularly convenient, especially if you have a lot of automation about it, and you can create release candidates and just pass them along for testing. But there is another step that is called dev artifact, and it can also be used for many reasons, like deploying to a dedicated machine for developers or sharing for integration. So this is generally better than to just provide the branch. So a dev artifact is something I relate to when I mean a unique state of computer software during development. It might have many reasons to exist, but some of them I've mentioned. Now, when we talk about this, it gets kind of difficult to maintain. You're using the just 3 versions separated with dots, because, like, you know, if we bump the version for building a dev artifact, and it's 1.0.1, and then we pass it along for release candidate as a release candidate. It's going to be 1.0.2, and then we create a release, and it's 1.0.3, and we kind of lost 2 versions for no reason. But when I told you about semantic versioning, I didn't tell you all the truth about it, because this scheme also describes additional information for versions. And the thing that we can use for our release candidates is called pre-releases. And a pre-release may be denoted by appending a hyphen and a series of dot-separated identifiers. I'll give you some examples of how this can be done and achieved, but generally you can just create a version and then append the pre-release postfix to it, saying that this is not the release version. There are some regulations. We'll skip them, so they're quite obvious. They mustn't be empty. They must follow the patch version, not be put anywhere in the middle, and they must comprise only of ASCII characters, and they must not include leading zeros. I mean zeros at the beginning, not zeros at the end, because at the end something is trailing, as you know. As for dev artifacts, I don't think it's the official way of using it, but one of those could be. It may be denoted by appending a plus sign and a series of dot-separated identifiers. It is not probably the original intention, but to me it really fits the approach. When you have a dev artifact and you specify the number of the build, because during the development process you can create multiple builds being within the same branch and just sharing them, and everyone can differentiate which is one, and they can switch and fix the integration. So if you have a bug, but the bug was discovered during the integration process and the version was not released was not created as a release candidate, you can create a new build. So you just save up on versions. This is mostly convenient. And when we talk about the build number, we generally put it after the pre-release, and if there is no pre-release, we put it after the branch. So an example version flow would look like this. So if we have a dev artifact of version 1.0.1 and the build is, I don't know, it's some kind of commit hash, and we create a release candidate from that, and we say that it's release candidate number 1, because there probably can be more of them, and then we find out a bug and we return it back to development, and our next release release candidate is created for the fixed version of the previous state plus a new feature, and in this case it's going to be a dev build for 1.1.0 and a commit hash. So you can like split them around as many times as you like, and then it comes to a release candidate of version 1.1.0, and it has a release candidate version of 1, and then it goes to production as version 1.1. It didn't have 1.1.0. It didn't go out as version 1.0.1 to production because you had like all the disjunctions in the process. But finally, you can extract the direct flow of what happened with your code and trace it to understand the changes before they came to production. So yeah, you'll have many more versions existing in your version control system related to the process before it becomes version 1.1.0. But the main thing here is that it's a linear flow. All of the tags, in fact, stay there for history. They're never getting their way through to production, but they help us to build this way. To build this linear flow. And just to recap, semantic versioning and versioning in general improves communication because it helps you better understand what's going on. It helps you to provide your users with information about your changes and stuff like that. It provides transparency because you can see the changes that have been made and understand the efficiency of what you've done. So for every single version, you can understand the depth of the changes and the amount of the changes. It also gives you more space for automation because for every single version that you release, you can automate it to have a dedicated, specific way of automatic things to be done. This is very convenient for like creating testing environments or stuff like that. So it's up to you. It's just another hook you can use in your CI/CD. On the other hand, versioning is quite adaptable because you can kind of jump in at at any place of your project, and even if it's been going on for like a couple of years, you can just create versioning at a very simple step in a very simple way, and then adapt it to the process of your project development. You can create changelogs later on. You can impose conventions based on the conventions that were accepted on the project and stuff like that. It's simple to do. Generally, you don't need to know anything specific, and I think most of the things that I've told you, you already know. You just probably don't use them, and it's not very difficult to do it. And the best thing is about versioning is that it's super easy to integrate, because you don't need anything else. You just need everything that is already given to you by Git or your other version control systems. And the approach taken can be very simple, but to make it even more simple, we're going to spend some time coding a tool that will allow us to do most of these things. And to do it, we'll have like 10 minutes break to prepare for the code time. Here is a tiny link that you can take. Raini, CBHWSVAC. I don't know, just the first letters of the name of the workshop. There's a QR code that you can use. So grab the code behind the link and fork it to your GitHub account. It's located in GitHub. I'll explain you the reasons why you should probably fork it, but if you don't feel like it, just clone it to your machine and we'll move on. So I'll set up a timer for 10 minutes. If you have any questions, please ask me in the chat. I'll mute my phone, mute my microphone, and I'll try to come back to the chat and we'll talk. Okay, so I hope we're ready to start. I'll open my code editor. This is VS Code. You can use any one of those. And I have the code forked and cloned already. So just to get you acquainted with my editor, I have the file picker on the right. That's because I always close it, and I don't like when it bumps my code left and right all the time being on the left side. So yeah, this is it. And let's look through the contents of the repository in the dev branch, which must be the default branch you switch to. Let's look at the README. That outlines what we're going to do. The app that I've called inversion is a tool in JavaScript in Node that evaluates the changes since the previous version, deduces the next one to be released, and it optionally generates a changelog in Markdown for the new version. And this is the usage pattern. We have node src. We'll use MJS, which is available in Node since version 13, and it will accept optional flags, that long options rather, that we can provide to amend the behavior of the program. We can provide a patch long option to force it to bump patching version, minor to force bumping minor version, major for major version, and we can provide a changelog option to create a changelog instead of emitting the new version. So this is it. This is what we're going to do. This is the description of how to run this thing. npm start will execute our program, npm t will execute the tests. There is a section about what can be done after we complete the workshop. So this is why I ask you to fork it, not to just clone it, because in this case you could, if you decide to do all of these things, you could send me pull requests and we'll review and discuss your approaches. So there are several tasks. Some of them are easier. The most difficult ones are marked with asterisks. This one is more difficult. This one is difficult as well. This one has 2 asterisks. It's like superpower code. So we have a package JSON, which doesn't have a lot. I created it to simplify usage of the script, not to write node, SOC, stuff like that. So it doesn't have any dependencies, as you can see, because I wanted to use jest, but for a number of reasons it doesn't yet support MJS, so I create a clown. A clown is a kind of jest, but it's a clown. It will work locally. You don't need to do a lot. It just works. It does some things. It provides like expect to be equal, expect to be instance of. It provides some coloring of the output, and we have the describe and the it thing, and also we have the it to do thing. It's just for you. I'm not using it for anything, but that's okay. Probably will use it for some reason. I don't know. We'll see. I also created the spec for it using itself to test itself, and I have a set of tests for everything we're going to do during the practical part of the workshop. So in index.js, I have all those things imported, and all of them are commented because we don't have files to be imported. MJS will throw it as if we try to import something that is not there. So I just commented it, and we'll uncomment all the stuff that we need as soon as we implement it. So it currently has import for internal tests, and if we open the terminal, if you use Windows or Mac, doesn't matter, you can use, click Control tilde or Control backtick, and it will show up the terminal if you have like the default key bindings. So I'll just write npm t, it's outlined in the package JSON, and it will execute tests. So yeah, it does. Looks kind of similar to what jest outputs, a bit different, but it wasn't like the goal of the workshop to create an equally working jest. So this is it. It tests if we go to clown spec node.js and we open a test and change something, what it's going to do is going to fail at us using assert node.js, assert library. It will show us a red cross and it will bail from executing all the other tests. So it doesn't go through until you make all your tests work in the order they were defined. So if we fix it again, it does 3 tests. If we have a problem, it actually did only 1 because I've broken the first one. So this is it, not that much. We'll just go through all of the things that we have here. And we also have index.js that has nothing in it, and SRC is going to be the folder where we'll have our source code for what we're going to do. And for making it more convenient in case you get lost during the flow, because I think I will be a bit fast in doing everything, we should know that we have, let me clear my terminal, there are git branch, I can type. Yeah, there is a set of branches. In case you get lost while we work on the functionality, you can wait until we complete and then use the branch where you stopped or failed. So it's gonna have all the same code that we're going to write to type right now, but it will those branches also have additional comments for you to remember, because not everything is obvious in what we're going to do. So to do the application we're going to implement, that is outlined here in README. Let me close the terminal. Sorry. Yeah. So to implement this, we will definitely need some kind of interaction with Git, because it's unknown for Node.js per se. And to do this, we have a special function in Node that is available for us that allows us to execute other commands in our CLI, and we'll use this function called exec_sync. It's okay to use sync here because we're not expecting any input, output, high load and stuff like that. We're going to just linearly go one command at a time and do it, so it's okay to like block our main thread. And we use this we'll use this command to kind of get the result of what Git tells us about it. So what I mean is we can open our terminal and pop up into REPL, and to get into the REPL we can type node and we'll get there. A REPL is a place where you can like make your dreams come true. You can just type any kind of JavaScript that works in Node and it will magically work here. So let me show you what it does. So we can say const, I'll write the common syntax with require. So you don't really need to type it. I just want to show you what we're going to do in case you are not familiar with it. We require a module called child process. You can press tab when it auto suggests you so that it works. Okay, so now we have an exec_sync variable that allows us to do it, and we can say that our exec_sync can be called, and it expects a string which represents the command we want to execute. So if we say echo test and we hit enter, it will return us a buffer. Not really what we need in our code, because we're not going to like use streams and stuff. So to amend this behavior, exec_sync also accepts a second argument, which is the configuration for what we do, and it's an object. And this object accepts encoding, and we can set it to UTF-8. Luckily, JavaScript is UTF-8 native, so we can use it. And if we do it, it returns us a test/n. And if we exit, you need to Control-C twice to exit the REPL. If we say echo test, it actually does kind of the same thing. What I don't like about this is that when we do something with exec-sync, it appends this /n. /n means next line, so this is then to, like, you know, make some space after we execute the function so that our next our terminal will get to the next line. This is not what we need to achieve, and it's not the desired behavior, so we need to trim it somehow. But we'll get on next to this. But there is another thing we should know about exec-sync. Let me input it again. You can put the arrow top button to get the previous lines in REPL. By the way, I got to REPL again. If we exec-sync something that doesn't work, and we say echo without h, for example, we get an error. We get a buffer. We need to, like, we still get an error, so we can see that there's an error. Check exec-sync error, and it's not readable because we didn't provide encoding. Encoding UTF-8. So if we try to execute a broken command, this is it. We get the error. We get the definition of the error, encode error, command failed, echo test, and we also get this node.js error that was created for us. And the problem with this is that we get this thing printed to the console, and if we execute this function in our code and we want some clean and understandable description, it will still throw at us this message during our execution process. Even if we capture the error, it will still write to the console, and this is not what we want to do. And to fix this problem, we can also use additional option that can be passed along to the function, which is called stdio, standard IO, input output. stdio accepts either a string or an array. If we pass it a string, the default value is pipe. It's going to, like, take what exec-sync does in fact is that it creates a new subprocess and executes the command there. And doing this, it gets all the output from that command and pipes it to our current process so that we can use it. And as it is a string, they're connected via a string, and we get a buffer by default. And the problem with this approach is that when something breaks while executing a shell command, the output goes to a different stream. There are like 3 streams: standard input, standard output, and standard error. And all the error stuff goes to the error. And when it comes to that, the error message gets displayed in our shell, which is not what we want to do. Alternatively, we can say that stdio can be given a pipe. We pass in an array, and we say we get a pipe for standard in, we pipe for standard out, and the third one is standard error, and we ignore it. Ignore. So now, if we do something wrong, we get the error in JavaScript, but nothing else happens. We don't get any output to the console out of our will. And this is what I wanted to achieve, that in case something happens, we just get what we get, and nothing else happens. We don't have any unexpected side effects in our code. Now, knowing all of this, let's quit the REPL, close our terminal, and let's create a new file in our SSC folder and call it exec_with.mjs. So this is going to be a place where we'll put a function that will exec for us. As you've seen, there might be an error when we do something, and most commonly an error is something to be handled, not something to be thrown. So this function is going to be the place where we capture our unexpected behavior when errors are thrown, and it will allow us to externally control the behavior of our execution process. So we'll say export const. By the way, if you didn't know, MJS allows us to write export stuff directly without module exports and stuff. A cool feature that appeared some time ago, but now it is available for us. We call it exec with, and it's going to be a function that will be reusable in many ways. So first off, I don't want it to be opinionated in terms of using exec-sync or something else. Probably there's going to be some kind of wrapper for exec-sync, or maybe we could use it with different approaches, a third-party library. So I'll just pass it an exec function from above. So I'll expect here a function that accepts a string, and we'll use it for that purpose. Then we want to have an external control over what happens if there is an error and if something fails. And in this case, we'll say that on error, we want to do something specific. Then we provide the command we want to execute. So the thing we see here is usually referred to as currying. Currying is the process of transforming a function of n arguments to n of n parameters to n functions of one parameter. So we can say that, just a quick explanation, that if a function accepts 3 parameters, then we can say that it is equal to, it's not equal to, but it is, officially it's called isomorphic to a function that accepts A and returns a function that accepts B and returns a function that accepts C. So the result is going to be the same, the application will be different. So this is it. This is what we do. Now, we have all the parameters in place, and what we need to do here is to try catch. So we need to try, oh sorry, not the right place. Inside the body of the function, we need to try to return exec function, and we'll pass our command to that exec function, and we'll also capture all the configuration we need in terms of our program for this. So we'll say that our encoding is going to be UTF-8, I can type, and it's going to accept standard IO of a pipe for standard in, a pipe for standard out, and an ignore for our standard error. And as I've said, we have this /n at the end that we need to kind of trim because we don't need it, and we'll say after we get this, here we'll get a string, obviously, because we expect a function that returns a string after executing it on the command. So after we do this, we could actually kind of pass it along differently, but that's okay for the case because this is the only application for this function exactly, so it's okay. And we're going to replace, and to do this we need to use a regular expression that will replace /n at the very end. The $sign means the end of the line, the end of the string. We need to replace it with an empty string. So this is it, but in case something happens, we want to catch the error that happened, and we want to return the onError callback on that error. So this is it. In case we try to execute some function with our exec function, so exec function in most of the cases is going to be exec-sync, so we'll pass along exec-sync here. It will try to return the result of this computation for that command that we provided, and if it fails, we'll execute onError, whatever it is, so some kind of function. We'll execute it and pass it along our error that we've got. So this is it. This makes our function more predictable. Even in case something goes wrong, we can control it from above. And in case exec function and onError callback provide this return the same type, a string, we can say that now in this case, whatever the input is for the command. So for any command we're going to execute, we're gonna get back a string. So this is called closed principle. So we never provide any different data type in case this thing returns a string. So I think this is it. We can save it, and to give it a go, let's try to right here we'll exec with. So let's give it. Let's import exec sync right here, just for fun, from child process. Yeah, this is it. So we'll exec with exec sync. We'll pass it along on our own error. We'll kind of ignore the error we get. We'll just say oops, and then we'll provide a command. For example, echo hello. So, and we'll console.log it. So we can see what the function returns us in this case. And in the terminal, let me clear it. Command K on Mac if you're interested, to just clear the screen in terminal. So we'll say node soc exec with MJS. It says hello. This is what our function returns. If we did echo hello, it got passed along to the try catch. It executed the command, trimmed the /n, and finally we got the result. So echo hello returned us hello. There is one /n here, but this one is imposed by console.log, not by our function. So if you want to see if we just delete this and re-execute the command, we'll have like 2 blank lines. So one of them is added by console.log. This is how it works now. Now let's break it. If we say again echo without change, what we're gonna get is oops. We don't have any error. We don't have any unexpected behavior. We just have the oops. So it kind of works. I think it's okay. And let me close my terminal. Let's remove all the things here. So let's preserve our clean, nice BO function here. And let's go to tests. And this is the first one, 0, 1 exec with. So we have a set of tests here. One checks that it works in case something is okay. Another tests if something is not okay. So if we go to tests/index.js, we can uncomment this test set. And what we see here, if we open the terminal, you remember we had the clown spec enabled. Now if we npmt, we also get tests for exec with, and it works. Great, so we're done with it. This is one of 2 preparation steps that we need here. In case you need some help, or you got lost, or you didn't keep up with the pace that I have, you can, I'll show you my presentation. You can go to this branch, check out 0/1/exec with, and you're gonna get the same code that I have. But apart from that, we'll continue. Now next, what we need to do is our part 2. It's a pipe, some kind of pipe. Let's talk about it. So let's create a new file and call it pipe.mjs. So if you've been programming for quite some time, you've probably heard of compose function, or probably pipe function, which is the same compose, but it works the opposite way. So a pipe is something that accepts, let me comment it. So pipe is a function that first accepts a set of functions to be executed, and then it accepts the initial value. For example, I don't know, hello. So when we just create a pipe, it's just a storage. It's kind of a function that wraps up the logic of all the functions passed along. So it doesn't get executed. It just like accumulates all the execution, and we have it bundled in one thing. And then when we provide the second argument, in fact, what pipe does is that it executes all the functions one by one. If we talk about compose, it's going to go right to left, so it will execute F3, then F2, then F1. And when we talk about pipes, it's going to execute F1, then go and execute the F2, and then F3. And what it does is it takes the initial value, passes it along to F1, and whatever F1 returns, it passes it to F2, and whatever F2 returns, it passes it to F3. And whatever is returned by F3 is what is returned from the pipe. So this is how it works. We'll see implementation in a second, but what I'd like to suggest here is to make something a bit more complicated. So pipes are good. I mean, you can create a pipe, and you can imagine that, for example, our F1 is in fact a pipe of F0 and FA, I don't know. And in this case, we can pipe to get a function, because pipe returns a function, and then pass it along to another pipe as a function, because it's in fact one function, not two functions. In fact, the good thing about it is that this thing is equal to this thing, and that's okay to do so. It's convenient and nice, but I don't really like the effect that it imposes when we kind of compose many things, and the code in the end gets kind of chunky. You've got a lot of small things, you compose them together. I mean, that's a good idea, but it's not very readable. And what I want to suggest you is to create not a pipe, but a pipe with a capital P. So to do this, we'll say that we have an export const pipe, and our pipe will be a bit more complicated. So it's going to accept our initial value, but it will return us what we do for an ordinary pipe is that we would accept a set of functions. I'll say, okay, I'll be very verbose about what I type. So functions, we accept some functions that we want to pipe. And then we would accept the initial value, and then we'll just reduce the functions over that initial value as the starting accumulator. But what I want to do is I want to return an object instead. So this notation, if you don't know, allows us to return an object in arrow functions without like the common way would be to open the function block and return an object, but this is kind of a shortcut you can use. So we're gonna create an object and return an object, and this object will provide us a run method. And before doing this, let's try to implement our pipe, ordinary pipe. So when we create a pipe, what we need to do is to accept a set of functions. I'll write fns, and then we need to const pipe equals, we accept functions, we then accept x initial value, and what we need to do is to reduce the functions, and the reducer will accept an accumulator and the value, and then something is going to happen, and we need the initial value as x, so we'll start reducing with what was passed. And if we know that we are reducing functions, an array of functions, then we know that this thing is a function, and we need to execute the function, and as we are reducing, we're going to get what this thing returns, And this thing, in fact, on each iteration returns the previous result. So if we've done this for the first time, we'll do it on X, and then we'll do it on the accumulator. So we can say that this is the previous value. And we need to execute f on the previous value. So this is the pipe, this is it. And in fact, what you need to know is that this is also our run. When we create an object, we don't actually anticipate the initial value to be provided to it. We'll create a run method that will accept the initial value. I'll call it x, just for the sake of simplicity. And what we need to do is, in fact, to let me briefly say that I think you've got it. This is functions. We'll just say fs. I just like things to be concise. Apps, I mean functions, many of them. So we need to functions reduce the same way, and we'll take we'll just say that this is an accumulator, this is our function, and we need to run function over our accumulator starting with x. So this is it, and if we would do pipe the ordinary way, we'll say pipe, pipe the small one, we'll say pipe, I don't know, string, and then we can use .3 here. So then we'll accept an x and say that we need x to uppercase and stuff like that. Now, when we talk about this thing, it's going to be the same. I mean, we will write it this way, and then we'll say, okay, now, I don't know, 1. It's a stupid thing to convert it to uppercase, but whatever. So this is how we would execute this. But when we talk about our grand piper, we'll say, okay, pipe string and x will x to uppercase, and instead of like running it, because we can't run it because it's an object, we'll say run me this thing, and we'll provide 1 as an argument. So this is not a big difference, but this approach allows us to go further with what our functions can do and what our function compositions can do. It's not the official term, it's just completely made up, but I call it a pipe because we're gonna pipe in a way. And to make this effective and not just be a pipe that everybody uses, what I want to do is to be able to have one pipe that does something and then another pipe. So if I have, let me comment this. So if I have a pipe of a function 1 and a function 2, and I have a pipe of function 3 and a function 4, I want to somehow join them and get a new pipe that is equal to pipe of f1, f2, f3, f4. So in this case, I could be able to kind of bundle up some sets of functions that I want to use in specific scenarios, and then kind of create ground pipes from those that will include a pipe that does this thing, then a pipe that does that thing, and moreover, I will be able to kind of extend the functions that I provide here. I'll show you in a minute. So, as you know, this thing is called an operation, and here we get to a very interesting topic. Let's recall some mathematics. If we have 1 plus 2 plus 3, it doesn't matter in which order you execute those operations. So you can first add 1 to 2, and then add 3 to it. So it's going to be 1 plus 2, 3, 3 plus 3, 6. But alternatively, you can first add 2 plus 3 to get a 5, and then add 1 plus 5 and get a 6. This thing, I mean, this feature is called associativity. Our vision of how we do things is associative. It doesn't matter in what order we do this. I mean, it's not always true. I mean, this is not about the law that you can say 1 plus 2 plus 3 is equal to 2 plus 1 plus 3. This is this is not directly related to associativity. Associativity is just about the fact that we can just first compute this and then compute this. Alternatively, we can compute this and then compute this as a result. So it doesn't matter. Why associativity is convenient? Because this is natural behavior that we can observe in many scenarios. And the same thing can be applied to pipes, no matter if it is a pipe that we've done in the way that everybody does, with pipe that accepts a function and then accepts a value. Returns a function that accepts a value. Or we do a pipe this way. But when we do a pipe this way, we can say that this can be seen as a semi-group. A semi-group is a kind of structure that comes from mathematics, and semi-group is in fact a combination of a set of data types. So it may be 1, 2, and 3, for example, is a set of data of the same type, and an operation on that type. So a semi-group is something that means, being a semi-group means that if you have a set of values and you have an operation that can be applied to any two of those, it must be a binary operation. Plus is a binary operation. We accept two values to return one value of the same type. And being a semi-group means that we can apply a binary operation to any items in the set in any non-specific order and get the same result. So this law can be applied by us, and we can recall different friend of ours which is called array. We know that array of 1 and array of 2 and 3 can be turned into an array of 1, 2, 3, and the thing to do it is called concat. So interestingly, if we have an array of 1 and we have an array of 2 and array of 3, again we have a data type we have a set of the same data type. It's an array. It's a set of arrays, 3 arrays to be precise. And in fact, it doesn't matter if we concat 1 to 2 first and then concat 3 then, or if we first concat 2 to 3 and then concat it to 1. We'll get the same result. We'll get an array of 1 to 3. So we can say that array is a semi-group because it has an operation, a binary operation, which accepts 2 items of that type and the data type that we have. And we have a set that allows us for this operation to be applied. So this is it. That's it about the theory. Let's do the same thing for our pipe. I think it would be readable to call it concat as well. And our concat is going to accept another, let's call it other pipe. So in concat we accept other pipe and we'll return a new pipe. And that pipe will include all the functions that we currently have as an array. So we'll pass them with the rest operator, and we'll concat it because internally we have an array. We can concat array of our current functions with the functions from the other pipe. But the problem here is that having this approach, which is, by the way, a cool way to create private properties in your objects, there is no literal way to break up into something that was passed along to this constructor function, because this thing is bound to the closure, and there is no way to get into the closure. Any valid way to do so. The object itself doesn't have reference to this fs. just has the concat in the run. And usage of those functions is provided by the fact that they are bound to a parameter of the function that created this object. So to do something like that, we will probably need to like give access to those functions in our object. And in this case, we can say that we take our functions provided as a closure, and we concat to other pipe functions, and they get available. But the problem with this approach is that I don't really like that it's publicly available. I really enjoy that I can use it. It's like the privateness of JavaScript code that is so hard to achieve. And this is why I suggest to borrow a trick from our friend, we'll call it fs, and we'll create a symbol, or whatever that is called. I don't care. Any symbol will do. So I'll just create a random symbol, and I'll bind the value to that symbol. I'll just never export it, so nobody can use it. But in terms of our context, it's okay to have it. So I'll refer to other pipe functions via the symbol, and I'll make the functions available under that symbol. But outside this specific file, there is no way to kind of break in here. We cannot like access it because we don't know what this is, in fact. Now, I think we're ready, but I'd like to extend on why we're doing this. During the process of making this software, we'll kind of we'll have multiple steps that we need to achieve. In fact, there are 8 of them. And during the process, we'll kind of need to go further and further, deeper and deeper into our execution process. And doing this, in different places, we'll need different things that we created before. So as you'll see in the process, we'll reuse content not only of the previous function, but also of the functions that were executed way before that, like 2 or 3 functions before. And in this case, it is very common to like return tuples, but I think it would be nicer if we created a way for us to work with objects. So if we recall what a function is a pair of the incoming value to outgoing value. So what I mean is we want to create a mechanism that would allow us to work with an object that comes in as an argument and return an object that we return in the end. But the problem is, in this case, we would have to kind of spread if we have some kind of app that does something, I don't know, and we'll have to accept we'll call it context. It will have to always accept the context, do something, and then in the end it must put the result of its computation plus the context it had. So this thing is going to get kind of boring very quickly, and I don't want this to happen, but I want our functions to be available and reusable in many cases. So what I suggest to do is to write a wrapper for our pipe that will do all the dirty job for us. And to do so, let's create first a function that we will call extend. This extend function will accept some kind of function, and it will accept an object. Here, I don't use access, as you see, because like in this case, I don't care what it is completely. I don't need it. It could be absolutely anything. But in this case, I state that I want a function, then I want an object, not just x. So x's are not like arbitrary things I put everywhere, and neither should you. Here it is not important, but here it is. Or we want to create a function that extends the object, the context object, with the result of the computation. And in this case, what we say, again, we use the shortcut, that we want to spread our argument object, return it, and also to spread the result of computation of our function on that object. Maybe seeming kind of complicated, but in fact this is easy. So if we have let's do console, no, I don't like it, let's say const res, so we have a result. Our res is going to be, we have extend, and we'll pass it a function that returns, so it will take x, and it will return an object that has y equal to x, and then we pass it along an object that has x of 1, and we try to execute this. So we'll say C. So we have res. Let's console.log. Oh, sorry. I think I've done something wrong. Let's fix it quickly. This is it. Okay, we return an object. So whatever the object was, I don't really need it, all of it. I just want to extract the x of it, so I need kind of object that has an x. I want to extract that x and return an object that has y equal to x. So we pass it along the x, and it's going to be 1, and let's see what we get as a result. And as a result we get node.js pipe.js. As a result we get an object with x and y. So our function didn't return the x. This is what extend did. It preserved the previous computation result with what we created. And the benefit of using this, as we'll see when we use it for pipes, is that we can no longer bother about returning the previous values in the state. It's going to be convenient, and to do so, we don't even need to create a new pipe. What we need to do is to create a new wrapper. So instead of the pipe itself, we're going to create export const extend pipe, and the extend pipe is going to accept functions as well, but what it's going to do is going to return a pipe, and for all those functions we're going to map over each one and apply extend on it. So in this case we'll use extend and pass it a function, and as soon as it gets run, it'll get an object and it'll do its job. So if we say const pipe, no, let's actually do it easier. So pipe, we can pass it, let's run it with x equal to 1 again, just for the sake of simplicity. And if we destructure what we get in the first function, and we'll return an object that assigns x to y, and we, by the way, we can do funny things here. We can pipe and pass along a console log here, because why not? It's a function, we can execute it. If we do it, we only get a y. That's because our function was applied to x equal to 1, and it returned an object which has y equal to x. But if we replace it with extend pipe, sorry, we had a pipe. If we replace it with extend pipe, we'll get x and y for free. So this is the reason for doing this. I hope you got it. Not that difficult. If you have any questions, we can discuss it a little bit later. But I think mostly that's it. The last thing I wanted to tell you is, apart from discussing the semi-group, that I'll remind you is a data structure plus an operation that provides associativity. There is one more thing that we should keep in mind, is that some things in some semi-groups have this unique feature of having their identity value. To show you what it means, let's pick numbers again. So if we say that we apply, we sum up 1 with something. So being an identity means applying something, some kind of value within that data structure that guarantees that it does not change our initial value. So we need to do 1 plus something to get back a 1. And this can be applied to products. We need to multiply 1 by something to get a 1. And surely we know that 1 plus 0 equals 1, and 1 times 1 equals 1. And we can say that array, or let's call it I don't know, let's call it a box of pigs. We can concat it to something to get back a box of pigs, and that's an empty array, right? If we concat an array to an empty array, we'll get back that array. It's not about referential things and issues. Of course, it's going to be a new reference and it's going to be a brand new array, but that's okay. That's fine. That's what we anticipate. So we don't reuse. We don't have immutable. We don't have mutable data. We use immutable data and recreate all the stuff from the beginning. So this behavior, I mean, if we have some kind of, let me be a sophisticated guy for a second. In terms of some kind of data structure, we'll call it a semi-group. In terms of a semi-group of a set of values, if there is an ID value, I won't be following the standards, I just want you to see how it goes. So if we have some ID value and we apply our operation, let's use concat for this. I think it should fit for now. So if we have this ID value and we concat it to any other s, and we get s, this is called left identity. So if we provide some kind of value that on the left from the s and apply the operation and we get back the s, it's called left identity. Because it's on the left. I might be mistaken, it might be right data identity, but I don't think so. And the same way, if we have s and we concat it to some kind of identity value and we get back an s, that's called right identity. So this thing about identity is applicable in many places again, and all this behavior is called being a monoid. And monoids usually have a not usually, but they must have an identity value, and we'll need it only once, but let's create it and say that our static value pipe.empty. So we want to say that our pipe can have an empty value, so we can take that value and concat anything to it and get what we concated to it. So the result will not change. And as we're going to talk about functions, it means that pipe empty is a kind of function statically available on pipes that allows us to create a pipe, and now we need to do something that will enable us to pass it a function that does nothing. And luckily we have an identity function which does nothing, and it just accepts something and returns it back. Again, we use an X here because we don't care what it is, we just return it back. And using this pipe empty will never break our execution process, because we can create a pipe and this pipe does nothing, just accepts what you give it and returns it back. And the same thing we'll do for our extend pipe. And extend pipe is going to have a static property of empty, and that empty is going to return us an extend pipe. And now we need a function that will not break, but it must return an object We can go the same way and just pass it along to this, but this doesn't necessarily work, because if we return undefined, it will break our extend pipe. So it's going to be difficult probably to do it a different way, but what I think could be efficient and convenient is to create a function that just returns an object. So if it was an extend pipe before this extend pipe, and this is required for more nodes, then even if it captures some kind of current state that we're going to extend, we can pipe it on the right, and this thing will return an empty object. And if we pipe it on the left, I mean, we can cat it on the left first using an empty pipe and then adding something to it. So in this case, in the next function, we're going to get an empty context, so this is going to be okay. And if it's used in the middle, it's going to like share the previous state and the new state. So we're safe with this, and if we use it anywhere in our code, it's going to work. So now I think we're done with this, and we have a bunch of tests here for it because it's quite complicated. Let's go to index.js and just uncomment it. If we npmt, yeah, it kind of works. It checks for associativity, left identity, right identity. I don't do it for extend pipe because extend pipe is in fact a pipe, but the function is different, but data type is the same. It should preserve previous context, we check for it, and it should extend previous context with the computation result, so we've checked this as well. Yeah, I think it is we don't need anything else, so it was kind of fat section. I hope you're okay with that. You may ask questions if you like, but what I want to say is that if you got lost for some reason, you can I'll open my slides. You can git check out 02 pipe. This is the last function in our preparation code, and we'll be ready to go next. So now, what I want to do next is to actually start implementing stuff. The very first thing we're going to do is we're going to get our next version, our previous version. This is the place where we'll all start to achieve the result, because as you know, we're going to bump, but to bump we need something to bump from, and the notion that we'll preserve during the process is that we are going to try to ask Git to give us the previous version tag in Git. If it exists, we'll use it, and if it doesn't exist, we'll refer to like version 000, a version that didn't exist. This is our local convention, so it's not like the very important thing and the only way it should be done, but it's gonna help us in the future. So what I suggest is to like separate all this preparation stuff with actual code. So in our SSE, let's create a folder and call it pipes, because we'll store our pipes there, and we'll create our first file. We'll call it get latest version .js. So this guy is going to be responsible for getting the latest version, and to achieve it, let's import extend pipe from let's go back a folder and take it from pipe.js. Okay, so we'll use our extend pipe, and this is going to be our very first function, and we'll export const get latest version. You can use default exports, but I don't like them. They're not very convenient to me. We'll make a function that's going to be pure as it can be. So we'll say that give me an exec function. You can say exec function, but I'll just call it exec. And give me an exec function, and I'll give you an extend pipe that will contain another function, and that function will ignore whatever was passed to it because it doesn't rely on it, and we know that we are safe from like non-passing on. This is the context of the application with our extended pipe, and it will return an object that has a latest version key, and the value for the latest version is going to be the result of that exec that was passed to it. And now, bear with me, it's going to be a long command. It's going to be git describe match. Here we need, oh no, it doesn't work like that. We need text, backticks, because we need, I mean, we can use double quotes, but I want to preserve them for the command itself. So git describe match. We need to match it against asterisks 0 asterisk 0s to 9 dot asterisk. Actually, we can just copy it because it's going to be returned 3 times. I hope it makes sense. So we ask git to describe and to match numbers dot numbers dot numbers. Kind of looks like the semantic version. So we want it to be described, and we need abbreviated hash to be equal to 0 because we don't need the hash. We want to look at we want the description for the head, and we want to only include tags. So this is kind of long command that is quite difficult to comprehend, but what we need to know is that the git describe command provides a human readable definition of a Git object. The minus tags thing, it returns not only annotated tags but any kind of tags. This is the problem when we kind of create non-annotated tags that don't have any message. They're so-called lightweight tags. The abbrev thing equal to 0. We can customize the abbreviation version of the hash that will be returned with the human readable definition, and by default it's 7, but we can say like, okay man, I don't need any commit hashes, just set the abbreviation to 0. And the match is a pattern that we're going to match among all the tags that we have. And so yeah, this is actually it. Kind of simple. We don't need anything else, so it's going to bind to it. If something happens, we'll get that happened in the exec. So what I anticipate here as the exec is a kind of function that already ignores errors and knows how to handle them. So I'm not going to put any execution here. So to me, exec is just a function that accepts a string, returns a string, and I bind it to the latest version value in our object. So this is it. Let's save it, and we can actually start using our code. So let's go to index.js and start drawing. So what we first need, so it's the citadel of impure code we're going to have here in our application, is the index.js file. So we'll here we'll define our exec the right way we need it. So we'll export, we'll import exec_thing from child process, as we've deleted in exec with. We'll also import exec with from exec with MJS. We'll also import our new pipe that we've created and call it get latest version from pipes get latest version MJS. So now we're ready to use it, and what we need to do is now to create a function for get latest version that we can use in conjunction with the context that is expected from this function. So as I've said, our business logic implies that there might be no previous version. From the perspective of Git, it's going to be a mistake, an error, and from our side, it's not an error. It's just we need to capture it and return 0, 0, 0 instead, because there is no version. We need a string, so it's going to be 0, 0, 0. And to achieve it, we can start with const exec or else. It's going to be a wrapper function for exec with. We will pass it along execing. So this is the starting point. We can use exec or else, and now we can pass it a function that should be done in case exec fails. What we need here is to call get latest version. It accepts, so it's not, I'll remind you that it's not directly an extend pipe. It's first a function that accepts exec to return an extend pipe. So we need to give it a function. So we say that here we exec or else, as I've said, if the command fails, the get latest version get command fails, we say exec or else. So exec, and if you fail, just return me 0, 0, 0. This is it. Okay. Now we want to console log it. We can do it right here. Not very convenient, and I suggest to create a log pipe right now. It's going to be super simple. We'll create a log MJS in our pipes folder. It's going to be super easy. It's going to import extend pipe from go back and pipe MJS. So what it's going to be is just going to be expert const log equal to so our log will accept a logger function. Again, this is an abstraction that has very precise naming, and that was my decision from the very start, because I just want this to be used with a logger to log things. It could be reused in a million different ways. When if you see, that's kind of simple. We just return an extend pipe of a logger. This is from the perspective of function programming and function composition. It can be used in a million ways, but I don't want any abstractions in a very precise code that does a specific thing. So I just call it a log, and it expects a logger. Although it's just a function that accepts another function to create an extend pipe of that function. So this is just narrowing down the context of our code, so it's just done for convenience. Now let's move on. Let's move back to our index.js, and I'll copy the last string. If you're interested, it's Option Shift down for Mac, or Alt Shift. I believe Alt Shift down on Windows and Linux, and I'll take the 2 lines and say log here. Command D, probably, I don't know, LD maybe on Windows, to select multiple references in the same document, so you kind of get multiple cursors. At least for VS Code, it works this way. Now we have this thing that is able to get latest version using our get or else. Now, as we know, we can concat our pipe to another pipe, and now finally, as we now have again a pipe, we can run it, and we don't need any initial context, because this thing ignores it altogether, so why would we bother to pass something along here? And what we do now is we can npm start to see what's going on, and it blows up into our faces. So can I find child process? Yeah, sorry, I spelled this here. Okay, it's a child process. Let's go back to the terminal, clean it up, and npm start. Again, something else. Okay. Must be doing something wrong. Pipe.js, what's wrong? So let me see briefly what I did wrong. Get latest version and pipe from pipe.js. Pipe.js pipe. Did I do something wrong with the pipe? If it's not a function. Okay, I got what's going on. My bad, sorry. I pass it along a log, but I don't give log a logger. I need to console log it. I want logger to log to console. This is the problem. Okay, now let's npm start. Okay, finally we got it. So the execution of our command happened to return us latest version 000. If we have a look at our git tags, run none of them. What we can do is we can git tag 1, 0, 2 or 3, whatever. And now if we repeat our npm start, it's going to give us a version of 103. Git tag -d because we don't need it, but I guess you see the idea. If we don't have a tag, we get 000. Okay, so I think this is it. We now need to go to the tests and let's uncomment our first. So what we're gonna do now is npm t and see if it works. Yeah, it does. We have a test for it and it passes. Let's see what the test does. It actually checks if something is wrong. It doesn't check if something is right, but that's pretty self-explanatory that it does. So okay, that's it. Now let's if you want to see it kind of marks, so we pass our get latest version as it expects a function that just returns a string. We can completely ignore it and just say, okay, here's a string that returns you 100. Go give me back an object with latest version of 100. This is it. Okay, so now if you got lost in the process, you can check out branch 1 get latest version. I think we'll do a bit more and then we'll have a break, like 5 or 10 minutes for a break. Now I hope you finished. Let's code again, and what we are going to do next is we'll close this and let's hover this. Let's hide this. Now another thing we need to do, so now we have the latest version. We now need a way to bump those. So this is quite mandatory. So we want a way to provide the configuration from above and say that, okay, I need for the latest version, I need my patch bumped, or I need my minor bumped, or my major bumped. And let's create a function in our pipes that I'll call make new version m.js. So this function is going to be all the same. So we need to import extend pipe from pipe m.js. This is quite required. So what we need to do here is we need to take the latest version, and we need to take those minus patch things, and as we get them, we want to make an educated guess on what should be bumped and bump it. So if you remember, our get latest version returns a string, and we'll need to bump. So probably the most obvious decision to be made is that we need to take our version and to convert it from a string to a set of numbers. I'd say even a tuple of numbers. So let's create a function, an internal function that we'll call split version to numbers. And what it's going to do is going to accept our context. We only need the latest version from it, and it's going to return us a new object that will have a new version that we'll work with to preserve the latest version unchanged. And the new version is going to be a latest version that we split by a dot, or what's that? A stop, a point, whatever. And when we have an array of strings that represent numbers, and we want to map and just transform them to numbers. So this style is the same as we get a num, and we apply the number function to num. So we can just ignore this altogether and just write it in a point-free style. So now I think this was self-explanatory, but what we also need to do is to kind of join versions, join numbers together again, to get a string again. So somewhere in the end, we'll join the values inside the new version array into a string, and we'll create a function join version numbers that's going to be equal to so we'll get a new version, and it's going to return an array, an object that will have a new version that is going to be equal to our new version joined by a dot. So as we split it, we're now going to join it, and as we join with a string, it's gonna reduce it to a string because we have a string here. So now we can actually play fun with this and exploit const make new version is going to equal extend pipe of our split version to numbers and join version numbers. And this is the big benefit of using extend pipes, is that each of these is now extending the behavior, and the previous context is preserved, but here we do some computation altogether within one single pipe, and we can like ship it together as a single bundle. Now let's move on to our index and Option Shift down, and I want to make new version here, and now I'll put it right here below our first function and concat it to make new version. Okay, so it doesn't accept anything additional, so it's just an extend pipe, so we can concat to it. And oh, what did I do? What's going on? Sorry. Let's open the terminal and clear the screen, and what I can do now is I can npm start, and now magically I get the new version, and it's equal to the old version because, well, what we did is we took it, split it into numbers, and then joined into a string and pass it along to the new version, which is not exactly what we wanted want to achieve, but that's okay. Let me close it. Let me close this. What we need to do now is to implement the logic to bump the code, and this is relatively easy. The only thing we need to remember is that we'll need, if we take a look at the README, we need these things, and they come from the CLI, and we need to pass those values along from our index.js, the citadel of dirty code. And if you don't know, I mean, we have a very special thing called process argv, and we can have a look at it. So if we run this, we get here an array of strings, and if we say npm start, you need two dashes to when you use npm commands to say, okay, this is the command, and after these two slashes, pass all those things to that command. This is specific to using npm and some other tools, but it's like the divider of the values to be passed along to the internal commands. So we say maybe patch and maybe changelog, and if we execute it, we get the patch and changelog. So I hope you understand what it is. It's an array, and which means we can take all the stuff from it and pass along. The first two values are static. The first one is, the 0 index is path to node.js, and the second one is the location of the file we're running. So let's clear the terminal, clear again and close it. What we need to do is to create argv where we can just simply use the process argv and just slice the first two elements, drop the first two elements. So we get argv, which is a new array created from process argv that doesn't include the first two items. So this is perfectly it. And now we need to somehow pass it along to make new version, and the easiest way to do it is to say, okay, here's your argv. You can now use it, and all of these functions, in case they need it, will have argv available. So in our make new version, we can create a function const bump, and now we have access to our argv, and we also have access to our new version. So we're going to do it somewhere here, right? So we're going to bump blah, maybe. Okay, so we need to bump here before joining, but after splitting, because numbers can be bumped, strings can't. So we already have the new version as a tuple of numbers, and we have the argv available because we kind of lifted it into the context at the very beginning of the execution flow. And now what we are going to do is to check if there is something that we need in argv. We'll take our new version and add one to the dedicated place in it. So we can do it directly, running with a for loop probably, or something like that, but I would like to make it a bit more human readable again, and say, okay, bump. From the above, I will give you an option that is passed along and available in argv, and I will give you a, say, bump function. So, and then when you'll be executed, you'll be given an argv and the new version accordingly. And what I wanted you to do is to check the new version should be equal to if argv that was given to you includes the option that I say, then I want you to apply the bump function on the new version that we currently have. Alternatively, just leave it to be the new version that it was before you were run. And doing this, we have a very nice and concise way to say, okay, now bump. And if we have a patch in our argv, I want you to execute the following function. So knowing that we will be given a new version, which is a tuple of 3 numbers, and we are going to bump patch. We can say that our function is having a tuple as an argument, return tuple, what was it, in the zeros place, then return me a tuple and the value that was in the first place, and for the last number, which is the patch number, remember, 0 based, so this is the major, this is the minor, this is the patch. You can structure it here, actually, it's okay. And for this thing, for 1 plus 1, well, let me show you major, sorry, it's going to be destructured to major, minor, and patch, right? So this is the major, this is the minor, and this is the patch plus 1. So this is it. So if we have a patch key, pull off all the values that we have off of the array, and then return the major as is, return the minor as is, and return the patch plus 1. And this is how we get patch bumped. When we talk about minor, we say if we have a minor flag, then having an array of major, minor, and whatever patches, we don't need it because we're going to set it to null. Return me the major that it was, set the minor plus 1, and return me a 0 instead of the patch. Now, if we talk about bumping, if we have a major, we'll just pull off the major version because we don't need anything else, and we'll do major plus 1 and reset minor and patch to 0. So this is it. I think it's more comprehensive than some kind of insane magic and one function that does loops and stuff, and I hope it's gonna work, and let's have a look at it. We have it already available in index.js, and we can do it this way. Yeah, so we have a patch and a changelog, and our latest version is 0.0.0, and our new version is 0.0.1. And if I kind of remove changelog and say I want a minor patch and a minor, then we'll get a new version that is 0.1.0, because we first evaluated patch, it bumped 0 to 1, and then we evaluated this thing and it reset it to 0. So it's just the order matters. And finally, if we also add a major, oh, it'll hit the wrong value. So yeah, this is a major value. So we can see it works. Let's make sure about that. So let's go to tests and index.js and unlock the make new version thing. Okay, and now if we mpmt, okay, make new version works. I don't think they're like the best tests in the world, but they will at least give you some idea if you have something wrong. So yeah, I think this is it. we can go to index.js to see if everything is okay. Yeah, tests work. And now let's repeat our action with bumping. Yeah, no external console logging stuff. Okay, so I think it's a great time. Git status, git and everything, git status. And what we can say now is we've completed a big part of our application, and we're ready to commit. And I suggest you to commit as well. But the funny thing is, we've talked about conventions, but we didn't set them up anywhere. And what I suggest to do is to put our conventions right here, because we'll need them, obviously. As we've talked about it, we'll use conventions to deduce versions, and I suggest you to say, okay, so we have a conventions, and it's going to be an object with a patch value of something, some kind of string, a minor value of some string, and a major value of some string. So for me, I'll just use Gitmoji because it's fun and I like it. I'll say if my commit starts with bug : it means that I need a patch update. If my commit starts with sparkles, it means it's a minor release. And if it starts with a boom, it means that I have some breaking changes. So now I have those conventions, I can actually pass them along to the context of our application, but it doesn't yet need it. So let's just have it for no reason right now. And let's follow it because we'll actually bump the version of our application using our application in the end. And now again, git status, git add, and git commit. I'll say that I have a sparkles of add version bumping support. Now if I want to add longer description, I can hit enter and just don't put the double quotes in the end, and then press enter once again, and here I can add a larger description for what I did. And I can say that if patch minor or dash, really, not minus whatever, or dash major are provided to as command line options, the application bumps existing version accordingly. If there is, by the way, you can start it with a different line if you want. If there's no previous version, the app refers to 000 as the version. Nah, let's remove this redundancy. If app refers to 000, that's enough, I think. Okay, so this is it. I commit error. What does it mean by error? Okay, let's do something like that. No, didn't try to do this. I did not match any files known to get. Okay, I see what the problem is. There should be more. Attentive, -m, I forgot it. Never forgot it in my life. What's going on? Okay, whatever. So git commit -m. I need to put it in a message. So this is it. Now I suggest to make a short break for like let's say 15 minutes, and after we complete, we'll quickly complete all of the rest in 1 hour, I think, because all of the other functions are going to be very small, except for the last one where we'll work with strings for making a changelog. And I think that won't take a lot of time, so 15 minutes is great. And I'm setting up a timer. If you have any questions, please write me in the chat. Okay, so let's continue. What we're going to do next is we need to take care about one important thing that we've missed. So in case we execute our code and we kind of make an inversion, there is a chance that it doesn't require any patch or minor or major bumping, and if it doesn't, what we want to do is we want to quit. We want to gracefully quit from the application because it's not an error, it's just a state when we don't need to produce any values because there is nothing to produce. And in case we don't do that, we will actually finally provide the values that we if we npm start, we kind of continue moving along even though we don't have anything in an argv and our latest version is equal to our new version. It doesn't make sense because our new version is going to be the same as the previous one, and we cannot really expect it to work properly. If they are the same, we need to quit, and to do so, let's create ourselves a new pipe that we will call exit if no version MJS. This is going to be quite simple, so it will import extend pipe from our root folder pipe MJS, and then we'll export const exit if no version. That is going to be a function. So again, we're going to accept a function from above that we're going to call in case we have no new version. So in fact, again, it's not going to exit, it's not going to be that opinionated, it will do something specific, but as we're not going to reuse the function that we're going to write, I think sticking to specificity in this case allows us to better understand what we're going to achieve. So it's not like the silver bullet and something you should always do, but in this very case, I feel that this is a good idea to be completely specific, even though the implementation will not be that specific in this case. So we'll take on no new version function, and we will return an extend pipe that will contain a function that will need the latest version and the new version. And let me clean some space here. So what it's going to do is it's going to validate if our new version is equal to our latest version. I put double equals, I don't put triple one because, I mean, why should I? They're both strings, I don't care. So if they're equal, it means that we need to call the no new version thing. And if it's not, we just return an empty object, and we do it for the sake of the extend pipe to be able to kind of compose our functions. So it will just add an empty object to our context, and that this will not change anything. So and if it is, we just need a function, and here we rely on the fact that this function will return us an object for us. I mean, I don't care if it does or not, but this is out of my business. I just call it. And in our index.mjs, where we have all the ugly stuff that we do, let's pull in this function and exit if no version. So after making the new version, let's concat to exit if no version, and it expects a function, and our function is going to be, so okay, we don't have any new version, so let's just silently die. So we'll say process exit, and the process exit exits the process, obviously, and it expects a status code, and our code is 0, so anything above 0 is considered an error, and 0 means that the process exited successfully. So we pass along 0, and we can easily check if it works, because if we have the same version and it exits at this stage, it will not log anything to the console, so we can just npm start, and yeah, nothing happens. But if we npm start with a patch flag, we can see what's going on. So we have it in argv, and our latest version is different from the new version, so it's okay. Yeah, now I think it's a good fix for a good bug. So let's git add everything and git commit with a message saying bug set no, not set, just add exiting if version is the same. I think that's self-explanatory. Okay, this is it. We've done with this, and if you got lost during the process, I suggest you to git checkout to this branch 3 exit if no version. This is what we've currently implemented, and this is step 4 out of 8. So yeah, we had 2 preliminary steps that were covered, so it's effectively 6 out of 10, so we're close to the end. And let's come back to our code, and let me clear my terminal and close it. What we need to do now is we are going to implement a function that will extract our latest version commit. So what we're going to do next is effectively the code that is going to be doing what is described in the README. So it will actually deduce based on the previous version, and it will return the new version based on that, and on top of that we can amend the behavior and force it to be patch, minor, or major, even if this level was not defined during the evaluation. So to evaluate, we need to get the list of all the changes since the previous version, and to get those in Git, we need not the tag itself, but we need the commit hash of the tag. And there are multiple ways to do this. We'll stick to like the most common ones, but we need to keep in mind that our get latest version in index.js is set up to lie to us, because if there is no previous tag, it's going to return us this string, and this string means there is no previous tag. Not very good, but I think it's okay. We'll bear with it. It's just for us, it means that our initial commit is version 0.0.0. I mean, it's not the way I would write production here, but I mean, I would write production code here, but this is an approach that I think it's explanatory, and can be done in better ways, but we'll stick to this. And in our get latest version commit function, we'll rely on knowing this fact, and in case our current latest version is 0.0.0, we will not get the commit hash of our latest tag, but we'll take the commit hash of the very first commit in the history. So let's create a new pipe, and we'll call it get version commit MJS. So you know what? We need import extend pipe from pipe MJS. And now we're ready. It's going to be simple mostly, but we'll need 2 external functions in this case. I mean, Not always, but I want this function to be dynamic and customizable as well. So I'll say export const get version commit. It's going to be a function that accepts exec on no tags. So this function will be used if we don't have previous tags. And another function is going to be called exec on tags, and this function will be called if we have previous tag. But by default, I want it to be the same function because I don't really care for now. If it's not passed, I'll just pick the first one. They might be the same, and they will be the same in production. This is just for testing purposes and controlling it from above. What we are going to return is an extend pipe, and that extend pipe will encapsulate a function. The function requires our latest version, and will return an object that has a latest version commit. And here we have a disjunction. If our latest version is equal to 0, 0, 0, so it means that we don't have any previous tags. So we need to execute this thing on a command that will give us the very first commit in our history. To do so, we need to run git revision list with so this will give us the revision list, but from that revision list we want to filter items where maximum amount of max parents is equal to 0, which means give me a list of revisions for all the stuff that has a maximum of 0 parents. And the intuition holds that if something is very first, it doesn't have any previous stuff and it doesn't have any parents. So this is our case, and we want that revision for our head, and this thing will effectively return us the commit hash of the initial commit. And if we have something different, we'll use exec on tags for this. And this is a bit shorter, but a bit more magical. Git show ref. So we ask it to show reference for our latest version, obviously. So I use template literals here, use backticks to be able to interpolate, and then we pass along -s. So now let's discuss what all this means. So revlist provides us a list of revisions, and we can kind of filter what we need, and we define from where the revision list should be built. And for this thing, we ask to show us a reference to something human readable, and we want -s means give me a hash of that. So one word of a warning that you need to remember is that this command may return you more than one commit. And this is possible. This is possible in situations when you have two or more separate histories in Git merged into one repository. In this case, it means that if you had like 3 Git repositories and you merge them into one repository, it obviously means that there are 3 starting points and there are 3 commits that don't have parents. So in this case, it's up to you to choose wisely which is the first one. But I'm not going to cover it, just for you to know that this might happen. Well, this is it for this function, and it's actually going to extract us the latest version. We just need to pull it in. We'll do it right after getting the latest version. So I'll just copy this line and say get version commit, and I'll concat get version commit. So what I want to do now is to pass it those functions we're going to use, and for those functions we need another exec_else, but this exec_else will in fact mean no other behavior. So if there is a mistake in one of these commands that we've created in our get version commit, in this one or in this one, if an error happens, that's super weird. We don't want this to happen. So if it fails, we want to exit the process. So let's create our const exec or exit function. That is going to be an exec or else. So we try to exec something, and if we fail, we know that we get an error from our exec with. And what we want to do is we want to console the error. If it has a message, then it should show me the message, otherwise just show what it is. And then we want to just process exit with an error 1. So it just means that something went wrong. And I'll just pass this exec or exit to our get version commit, because we don't want it to happen in any way. We could put it twice, but as you remember, the second one is optional. We don't need it. It will reuse the save of the first one. So this is it. Now if we open our terminal and npm start, it will boom at us. It says what? It says exec and no tags are not specified. I guess I've made a mistake somewhere. Exec on no tags. Here, and probably on not tags. Not tags, no tags. Okay, there was a typo. If we npm start, it doesn't show anything, but if we npm start minus patch, we'll get this thing. This is a hash of a latest version commit. So how can we check if it works correctly and Git didn't lie to us? We can use a git log and go all the way to the bottom. It's gonna be long. I mean, we could just run the same function that we've done, but that would be stupid because it doesn't check anything. So here we have the very first commit, initial commit by me on 6C1E420. So this is it. And if I close it with Q, by the way, it's what we got is the initial commit is 6C1E420. Yeah, looks like it's the initial commit because our latest version was 000. Now if we git tag and say I want git tag 100 and we rerun our thing again, it's going to say that our latest version was 100 and our new version is 101, and the commit hash is AB846C. And if we get log again, it must be the very first commit we see because we created the tag for the current commit, and it says AB846C. So this is it, and it says that it has a tag pointing to this commit. So everything works. Let's quickly remove our tag because we don't need it. Let's see if we have any tags. Okay, great. So we're done with this. Let's close the terminal. Sorry, and let's go to our tests. Tests index.js and uncomment this thing because we didn't test it, by the way, and this thing. I hope everything works. Let's mpmt. Yeah, it works. So all of it works. Everything is great. Now, what we need to do next is we have the commit of the previous release of the previous version. And now what we need to do is to take that hash and get all the changes since that hash to our current commit. And after that, we'll be able to do all the magic with it. So this function is also going to be, by the way, I really forgot about this. If you got stuck for a reason or no reason, I don't know, you can git check out for get version commit to get to the same state where I am, and that would be great. way to kind of switch to the current context. Now, what I'm going to do next is to implement the get changes. I'll create a new pipe. I'll call it get changes MJS. So you know that we're going to import. We're going to import extend pipe from pipe MJS. Now our function is going to rely on git again, because at this stage we have the previous version commit, and we can ask git to provide us with all the changes that happened since that commit hash. So we'll need exec once again, and after that we'll return an extend pipe that will have a function that exposes that latest version commit, and it will return us an object that will have changes, and those changes will be the result of a command that we define with the exec. So here we'll say git revision list. We need latest version commit to head. What's wrong with it? Expert const. Sorry. We need revision list from the latest version commit to up to the head, and for this time we just need one line. So this is not like the full implementation of how this can be done and should be done. It will completely ignore anything but the first line in each commit, but this is okay for us in terms of learning how to do this. So when we get our changes, we'll get the commits. By the way, we can have a look at what it gives to us. Yeah, let's take this commit in our history and say get revision list from this to head in one line. By the way, one line is just a format, is just a kind of format for our commits. It does nothing else. It just says give me the first line, and this formatting tool will return us all the commits that we have since the previous version, plus at the beginning there will be a 7-symbol abbreviated hash and a space. So we should consider this when we work with the commits, because we don't need the hashes. We can completely ignore them. We just need the strings, the definitions. I mean, you could use abbreviated hashes and to give a link to the change, but I don't need it. I'll just strip them because they're useless in the kind of changelog I want to generate. So what we should remember is this will in fact return us a string, because any exec returns us a string. But as you can see, they are on different lines, and we already know that to make a new line you will need to /n on each line. So we can write here split with a /n, and let me remind you that the changes must be reflected chronologically. And if we look at it, the very first thing we see is a bug that we just committed, and then we have sparkles that we committed before. Then there is all the stuff that I've done, and somewhere over there, long list down, there's going to be our initial commit. So what I want to do is to reverse the resulting array so that the very first thing will be at the top of it, because this is the intended behavior we would like to get. And after we get that, as I've said, I don't need this. You can omit this step and just preserve these items. I mean the abbreviated hashes here. I don't need them. I just want to map over the array, and for each change that I get, I want the change oh sorry, change to be sliced. And to be 100% sure, because this might change, there might be 8 of them, 11 of them. I just want to be sure that this thing, I mean, I haven't seen more than 7 of them, but they might happen. I know that when Git was planned and created, the abbreviated hash was invented to be to support like up to 12 characters within hexadecimal numbers, to be precise. So what we need to do now is to slice, and I want to be sure that it is sliced by the space, not the amount of letters and characters here, but by the first space. So I want it to be sliced by change index of a space, and as this will trim us to the space, as index of is 0 based and change in slicing is order based. We need to add +1 to it. Okay, this is it, and I think I'm done with the changes. And what I can do now is to go to index and import the changes, get changes, and we need to concat, and we need to get changes before making a new version. So we can say concat get changes, and we again, if there's something that happens, I just want to exit exec or exit, because I don't know if there's something wrong with Git. I just don't know how to handle it on my side. I'll just exit the process. So I think this is it. What we need to do now is to go to our index.js and comment. I hope it works. Let's npm. No, let me clear my screen. Npm t. So it got changes and it works. And if we npm start minus patch, it's gonna get us a list of changes in the right order. So yeah, this is it. The last thing we get is the bug, and the very first thing we get is a complete readme thing. Okay then. If you remember, the very first commit that we've seen in git log was initial commit, but for some reason when you fork, it kind of disappears. Probably it's related to the fact that I switched main branch, or I don't know. I'm not sure about it, but for some reason it just got lost. It should have been here, but I don't know why it is not displayed. So now as we have everything ready with the preparation, we can make it work so that our code will create new versions based on those changes. And this is going to be easy generally, but I want to implement it in a way so that we don't need to make any replacements for the make new version. I just want my new function, my new pipe to be concatenated before make new version, and I want it to work in a way that it just adds new options to the argv that we have in the context. And this way we could just reuse our make new version function, and it will just work as it did. So as we're going to need our conventions to define which commits do what, we'll just lift the conventions into the context of our application, and this is going to be fine. So if we now go to our pipes, what we need to do now is we need to create a new file and call it, I'll call it force bump .js. So it's not going to do anything else, but checking the changes and saying, hey, you must be bumped. It's not gonna be very complicated. It's just a small function that will, you know it, require us to input extend pipe, and will input extend pipe from our pipe m.js. Okay, so export const force bump is we don't need anything. It's completely internal. It doesn't rely on anything, so it's just going to work with the context of our application. So we can just extend pipe with a function. Yay! So what we need to force bump, first we need our changes that we got. Then we need our argv to be able to push the option that we need, and we need our conventions to validate against. So this is it, and we will return an object that will have an argv. So the only thing it's going to do is to update our argv, and to work with it, we'll need to see what our conventions are, and then for every convention, for every change, we need to see if they're not that difficult. For every convention that we have in conventions, we'll see if there is at least one change that matches this convention, and if it does, we just need to pass to push another value to our argv. So our argv is equal to our conventions is an object, so we need object keys, which are patch minor major, if you remember, and object keys conventions. Oh, sorry, I misspelled that. Conventions. I had TSOST, whatever. So now we can just reduce our code with the following. So we have an accumulator and a convention. I'll put a C here for convention. So when we reduce, we need two changes, find, and now we need to test. So here in index.m.js, we created strings, and we need to create regular expressions from it. I mean, you can create regular expressions right here, but in this case, it's not going to be reusable and transferable to JSON, for example. I don't like to kind of trim this flexibility from my application, so I'll just leave it as is, and my code will be capable of doing all the transformations. So what I know here when working with the force bump is that I'll need to create my regular expression from the value in the against the convention key. Let's call it a key because it's a key. It's not the convention itself. So let's create the function that will actually do the evaluation for us. The function is going to be quite simple. Oh, sorry, key. So it's going to be const test convention. It's a kind of function that accepts we have a convention, let's say a string, and it's going to be the convention string, and then it accepts a change, and what we want to do is we want to new regex of string test our change. So this will return us a boolean, right? So we need changes fine. conventions key. So if we find one, we don't actually need to find, we can just sum. If we have at least one in changes that matches the convention, we can say that we need to accumulator to return our accumulator concatenated with a, I know it's an ugly solution for the problem, but we have the key, so we need to put another item in our accumulator. Accumulator is our argv, by the way. We just need to in our reduce function, where it ends, yeah, over here. So we need to put argv here, and this is going to be our initial value. It gets passed along. So if there's no change, we'll just return the accumulator unchanged, and if there is at least one change that has that matches the conventions key, by the way, it's not this, it's this. This looks better. Okay, so we need to find at least one change that validates to true with our test convention against our current convention key. So if it is a patch and it says that our patch must start with colon bug colon, if it has that regular expression, so we need to return our argv, existing argv passed along as an accumulator, concatenated with the key with 2 dashes. So I hope it's explanatory what we do here. Not the most eloquent solution, but I think it's fine. Not the worst one, after all. So what we need to do now, because this is it, there's nothing else to do, we need to let's keep our fingers crossed and first go to our test and check if it works correctly. Let's npm t and comment and npm t. Yeah, it does. Okay, great. So I didn't break anything. All those reductions kind of get difficult to maintain. So now we need to import our force bump here, and our force bump can be called right after we get changes. So we can cat force bump. It doesn't expect anything to be passed along, so this should work. Now we can say that npm start with a patch will return us. We said, okay, man, I only need a patch. If you remember, again, I say npm start patch. If I run it, it says, no, man, your version is going to be 010. And it shows up my patch, and it also added the patch that was created because we had one bug commit, and then it also added a minor commit because we had sparkles this commit. So now it's able to make educated guesses on what the state of our software is. So we can even stop doing provision of those patches and stuff like that, because even npm start will be capable of deducing that next version should be 010, and I think it's great. We can use it later on. So it's a good place to git add everything and to git commit with a message of sparkles, because now we add ability to version based on changes. I think it is okay to do so. So npm start again, and we have this new change here, and it's again sparkles. We only have one minor, not two, because it happened once, because we checked with sum if at least one happens. We did a loop of 3 elements, which is not that serious, and cost and space and time expensive. So I think it's okay. And we're done. The next function that we're going to implement is going to be quite heavy. We need to make our changelog, and doing changelogs is obviously working with strings, and this is going to take hell a lot of time. So I suggest a 5-minute break right now until I don't know, we have like kind of small delay. So I'll just track for 5 minutes. I'll set up a timer for 5 minutes, and after that we'll continue. If you have questions, you can go to the chat. Okay, so let's continue on our journey. I'll close the terminal. Mostly the last thing we need to do, that's going to be a bit vast and not very convenient, right? Because we're going to make a string that is very big and composed of different stuff. So we're going to make a function that is able to make us a change MJS. So you know it. We'll import extend pipe from pipe MJS. So what we need to do, we're not going to use any external stuff here, so it's okay for us. It's gonna be kind of clean in terms of what we do, because everything we need is captured in the context of our application. We just need to export const make changelog, which is an extend pipe of some kind of function that returns an object. This is it, and let's start with the very bottom. So to make a changelog, obviously we need changes. We need the new version to specify it at the very beginning. We'll also need conventions, because we need to kind of put our changes in the changelog in a different way. So we need to first put all the fixes, then we kind of want to put all the features and so on and so forth. So it's going to be that way. What we want to return is an object that has a changelog, and the changelog is going to be a string. I'll just use template literals here. So it's going to be markdown, so the level 1 heading 1, you name it. We're going to put the new version, and then we're going to make like subheading for that. We'll call it, let's put breaking changes first. Breaking changes. So here we'll need to kind of filter out all the changes and put the changes that breaking changes. We'll just put a question mark here, and we need features and deprecations. I didn't create a specific type for deprecations, so let's say they're in the same category. I mean, you could do it the same way, the way you like. You can define different types additional to semantic versioning. That's just okay. You can create types for documentation or whatever else you want, but I'll just stick to the common things. And so yeah, we have 3 categories. One needs filtered changes for breaking changes, one needs filtered items for features and deprecations, and another one for bug fixes. And what we actually need to do here is we need to make a function that is capable of getting matching changes, right? And we'll just take all the changes and take the ones that we need. So to do so, this function will require a convention, and the changes, the list of all changes that we have, and it's gonna changes filter. So we'll go through the array, and I think you see the pattern. We are going to kind of create a regular expression from the convention and filter them. We could do it somewhere above. I just didn't want to kind of specify additional behavior for this. I'll just leave it as is right here. But we need this function we used in get changes, right? No, not get changes. What did it? We used it in force bump. We'll again need this function because we kind of need to do the same thing. We need to test a change for a convention. So I suggest to kind of export it from here, and in our source we need to create a utils MJS to be reusable, and we'll say that this is an export const test convention. So we need to not to forget to input it here. Input test convention from utils.js. Let's save it and let's copy this line. Now, by the way, you can just at any line click Ctrl+C or Command+C and it will copy the line altogether. So we'll just paste it here. Now we can say that we need to test convention against our convention, because it's gonna go through the same callback as sum. Filter has all the same stuff in terms of its work, so it's fine for us. And now we can replace this thing with interpolated get matching changes of breaking changes are conventions major, as you remember. Now index MJS we'll have patch, minor and major, and we want major to be the first. So here we say conventions major for breaking changes, and we want our changes to be passed along. We can copy this line again to this, and here features and deprecations are minor, and now it'd be like this. Patch is for bug fixes. So this is it, and in fact we can use it this way, and what we need to do is just to pull in, and we need to make changelog. So we need to make a changelog. We can make a changelog. I think the right place to make a changelog is after we understand that we do not need to exit and there are some changes that we can outline. So if we didn't exit here, then there are changes. There is a new version, and in this case we can make our changelog right after exit if no version. And now if we try to do this, we kind of get the changelog, but the stupid thing about it is that first off we have all of those spaces, so we need to kind of go to our make changelog and to kind of trim all those, and I don't really like to bother about it. Moreover, if we take a look at our terminal, we also have this breaking changes paragraph, but we don't have any breaking changes, so it's empty, and then there are empty lines, and then we have features. So this is not very convenient, and a good way to do this without bothering about all this stuff is to create a tagged function. If you've heard of them, we can create a function that accepts a tag. So I'll just call it a changelog tag, and I'll create a changelog tag function. I'll say const changelog tag is a function, and changelog function, tag functions accept an array of strings, all those string values that are between the in places that are not interpolated and do not include any real values, and they come as the first argument as the array, and after that we get all the rest of the stuff as single items. So the first one is going to be, if we go along, so we have new version, then we have breaking changes. I'll just say breaks. Then we have minor changes. I'll say features, and then we have fixes. So this is how it works. This is how this function works. So on every dollar square bracket, this thing will be available in the same order they're shown. So what we do next is we kind of override the behavior. So I put an underscore here because I'm gonna completely ignore this. I don't want to do it anyway. What I want to do is I actually know that I will have a version at this moment because I would quit in another case. And what I do is I say, okay, I need a hash sign, level 1 heading, and I want my, let's say just version. I need my version here. And I want a new line after that. And after that, I want to concat. So I'm going to concat with breaking changing, breaks, and I'll concat with feet, and I'll concat with fixes. But I don't want them to look the way they look. I want to do some magic around them because they kind of look stupid. This thing appears, although we don't have all of that. To put the headings because we kind of lose them with this approach. So I just make this more of a reference instead of being a real interpolated string. And I'll just make myself a function that will style all those things in a way that I need. So I'll say I have a const write to changelog function that accepts a title to be shown and the to be shown. And this function will first check if items array has any length, and if it does, the first thing I'll do is I'll start this with a new line. I'll put two pound symbols because it's going to be like a level 2 heading, and I'll put a title there, but only if I have items to be shown. After the title, I want a blank line, so I need two returns on the string, and after that I want to show my items. And when I show my items, I don't just want to show them as is, I want to map over them, and for each change I want to return a string that starts as a list item where I display the change, and after that I put a /n. So what it gives me is that So what it gives me is that I get a list of changes, not just changes as we see them here. So it's not the same way. Now what we need to do next is apparently to join, because in this case we get an array and we need to join the array, because in another case, if it joins automatically with type coercion, it's going to put commas. Actually, I think it did. Did it? We have one picture for some reason. Oh no, yeah, right, here it is. It coerced. So this is our first feature commit, this is our second feature commit, and there is a comma because type coercion from array to a string is just combining them to a string with a comma. This is not the expected behavior. So if we have it, by the way, this is length. So if we have items, we'll do this, and if we don't, we just put an empty string. We don't need anything else. That's it. So what we need to do now is to I think that's it. We can just instead of doing this, instead of those concats, I'll just say so let me put it to the next line. I want to write to changelog with a title of breaking changes. Breaking changes. I want to put the breaks. Okay. And for my features, I want to write. I'll just remove these two and copy it twice. Features and deprecations will include features, and bug fixes will include fixes. So yeah, I think this is it. And if we repeat, we kind of get a more structured view where we have a version at the very beginning, because it's going to be version 0.1.0. Then we have /n, an empty line, /n. Then we have our features and deprecations, because we didn't have any break-in changes. Then empty line, we have two features. Then we have bug fixes, and we have one bug fix. Okay, so this is it. The only thing I would like to do, probably it's optional, if you like you can do it, if you don't you can skip it. I want to remove those sparkles, because they're going to be repeating everywhere for each and every feature that we add. Like kind of a group of different types that mean this category. I mean, minor version bumping be okay, but for me it's just sparkles. If we take a look at our index.js, minor is just sparkles, and major is just boom. So there are no different types, and I'll just trim them, because they don't put any additional meaning to what I do. And when we get matching types, we've actually filtered through all of those, and luckily we have the access to the convention, and knowing the convention, we can just trim the value of the convention from the commit. So we've filtered, we have only those with sparkles, and we can now just remove the sparkles right in the same place right here. So I'll just make a const trim type, meaning commit type, is going to accept the convention, and then it's going to accept a change. What it's going to do is just going to take the change and replace. We'll create a new regular expression from our convention, and we'll replace with that regular expression, and we'll replace it with an empty string. So this is it, and I'll just map here and call the trim type with that type with our current convention. So now if I do it again, I'll kind of get the same changelog, but I don't have the bug, I don't have the sparkles, and it's kind of neat. Takes less space, and I don't have repetitive stuff that doesn't mean anything right now. So I think we're done. It works out in our index.js, and it kind of works in our test, I think. Let's go to our tests and uncomment our make changelog spec and npm t-it. Yeah, it works. It should create a changelog, and it does. It actually checks for a changelog to be created for a set of commits. So I can say we've done a good job, and this is pretty much it. It doesn't work as expected, because it doesn't return the real values, it just console logs it. But what I want to do is to, you know what, I don't want to execute this function for no reason, because if we take a look at our README, it says that it should generate changelog instead of new version if it has a changelog flag. So I think our citadel of bad code called index.js can actually do us a favor in this sense. I mean, we cannot break into the context of our execution process right from the outside, because it's impossible. We cannot do anything from the outside to the insides of the context. But what we can do is we can input our extend pipe from it's right here actually, pipe m.js, and I'll say that const make changelog if needed is gonna be a check. We're gonna have access to our argv right here, so we can say argv includes. So if we have that changelog long option, we'll bind our make changelog pipe to this value. Otherwise, we'll say that it is an extend pipe empty that we've done. So in our application, we will only make changelog if needed. So if we have the changelog, we'll do this, and if we don't, we'll do nothing. Effectively, we'll just return the context that we had. So this is it. Now, if we take it how it works and npm start, we're not going to get our changelog and save some computational time. And if we say changelog wow, I think I mistyped something. Changelog. Did I? Oh, I mistyped here. Okay, changelog. argv includes changelog. Oh, sorry. Save it. Now it will work. So if we have the flag, we'll create the changelog. If we don't, we won't. So now we have everything we need, and the very final step we're going to do is to change the logging approach. But from one perspective, this is a breaking change because, you know, we output all this stuff during the way, along the way. But on the other side, the thing was not released ever, so there is no backward compatibility because there's no way backwards. It's kind of the first version we're gonna do. So I don't think it's important right now. Let's just go to our log and let's make it super opinionated. And to do so, it's gonna be kind of easy. Let's replace the behavior, and instead of just piping to a logger, let's make it accept our new version and our changelog. And what it will do, instead of logging everything we have, it'll just use the logger to, well, it will pass along to logger. By the way, we need argv here as well. So we'll call the logger, and if our argv includes changelog, it will, I know, we don't need argv, it can be easier. Let's do it another way. If there is a changelog, then use the logger and pass it a changelog. If there is no changelog, pass it the new version. So we know that we don't have a changelog if it wasn't created, and if it was created, it means that we have the flag that we need. So this is it, and in our index.js we already have our logger function applied, and we can kind of try it. And if we say changelog, it's going to log our changelog the same way we created it. But if we don't provide a changelog, it's going to be our version. The last thing I would like to do to make it usable for all the scenarios is to say we don't need console log because it adds the /n thing in the end. I want const logger to be equal to process std out right, we need to accept the message. We actually need a string, and it will process std out, write the string. The reason between this and the console log is that this is a string, and when we write strings to it, it's not gonna add any /n's and stuff like that, so it's completely unopinionated. And we'll not call it logger, let's call it std out. So we'll use our log function to std out, and pass it our std out as an argument. So now, if we execute it, we'll see a weird thing. It's going to show us a % at the end. It says that there is no new line, at least what it looks like to me. For some terminals, it just shifts this line to over here, right after the value. For some terminals, like I do, it shows this % saying that this is the end. And why is it important? It's important because now we can say, okay, my dear friend, I want to git tag, and I want to run npm start. It says too many prompts. That's true. Let's git tag, and we'll node as a c index mjs. Yeah, it's done something, but if we look at git tag, we'll see this version 010. So we've created ourselves a tag with our application. What we can do else is we can do, like, let's play with it. Node ssc index mjs --changelog, and we want it to be output to changelog md. And now we have a changelog file, and it's empty. You know why? That's because we didn't remove the tag. Git tag -d 010. We created one, and since that tag we don't have any changes. But if we repeat the previous command, now we get a changelog. So this is it, our version, our features, our bug fixes, and we're done. So what we can do now, let's remove the changelog, get status, we can git add and git commit with a message of sparkles complete in version MVC. I think it's minimum and it's viable, so that's okay. At this point, I can say that we're almost done. I forgot to check our application, our log application with our tests, so let's repeat npmt. Let's uncomment the last line that was commented out for logs and npmt. Yeah, it works, so everything is okay. Let's git add again. Let's git commit. And for test, if I'm not mistaken, it's white check mark. Let me see, get log. I've done it. Yeah, white check mark. This is an emoji for tests. So let's say git status git commit -m white check mark, which means that we have tests, and add log tests. Yeah, this is it. So now we can git push, and we can start using this thing to be. We can add this thing to our CI and just kind of use it. It's not complete. It doesn't do many things, but I think it was explanatory that you can apply some tinkering to do this stuff. I hope it was interesting for you, and if you're interested in kind of improving this thing, you can follow along with what to the next section in the README. There are a few tasks. If you have any questions, you can ask me directly. You can write comments or stuff like that. You can kind of reach me almost anywhere. There are a lot of things that can be done in order to improve this application if you want to have some practice with the approach that we've taken if it is new to you, or you can just implement it the way you like, and I'd be glad to see how you do, and thank you very much for watching. If you have any questions, please let me know. We can discuss in the chat. I'll just reserve like 10 minutes before we complete. So if you have anything, just type to the chat and we're done. Okay guys, I don't think any questions appeared during the time. So thank you very much for watching. I hope it was interesting. Please share the information about the workshop and Raini in general if you liked it. And thank you very much. See you soon. We'll have a lot of